So which calibration standard should you be using for your measurement? Here I have our SMA calibration standards, or you could instead be using our PC 3.5 premium calibration standards. Well, some would say if you've got an SMA test lead, how do I know that's an SMA test lead? Well, all these connectors are the same physical size, same threads, same pin and socket dimensions. All of these connectors mate together quite freely and can be interchanged quite freely. When I'm looking at an SMA connector, I know this because you can see in here there is a white dielectric, whereas a PC 3.5 has an air dielectric. So there's some degree of uncertainty associated with that white dielectric there, and variability between connectors. But perhaps more important, when we have some dielectric material in connectors that are essentially the same dimensions, a dimension has to change, and you will notice here that the ring that forms the reference plane, that ring of steel around the white dielectric, that ring is quite thin, whereas on this one, where the air is forming the dielectric, we have a much thicker ground ring. Now those two rings are our reference planes, and I think it would be clear that if we were over tightening connectors, or if there are little bits of dirt in the connectors, then we'd be more likely to damage the reference plane, this thinner reference plane, than on this more substantial reference plane here in the PC 3.5s. It's also the case in SMA connectors that the plastic in part defining the positioning of the pin can be slightly more inaccurate than it can with the PC 3.5, although that one actually depends on the detailed construction of the SMA connector. And a good quality SMA connector such as these, made in essentially the same materials, with the same finishes, with similar precision techniques, the SMA dimension control is almost as good as the PC 3.5. So there you are. There are some physical differences, but as I say, all of these connectors are completely interchangeable. Now, when we receive a calibration standard, it has a serial number, and we are all probably familiar that when we use a vector network analyzer, this user interface is of the Pico VNA, the device that you see behind here. We load to the relevant ports the cal kit that is going to be used to calibrate that port. So if I'm going to use SF many zeros 3 to calibrate port 1, which is that male connector there, I will need to load onto port 1 the data for that cal kit. That data on that file, in that file, exactly characterizes the short open load and through on this cal kit. And likewise, if I'm going to use this kit is serial number 14, SM14. I'm going to need to load on port 2 the data. So I must use the correct data for the cal kits that I'm going to use to perform the calibration. Now, the data associated with the Pico SMA cal kits is not quite as good as the data associated with the premium kits, and this is because they're calibrated by us in a slightly different way. These SMAs are calibrated against short, open, load and through precision standards back at the factory, but the PC 3.5s use a TRL technique, and that gives us less uncertainty in the data for these cal standards above about 1.5 gigahertz. So premium standards, we could use them with these SMA connectors. Some would say that if there's an SMA in the measurement, because that alone brings some uncertainty into the measurement, you might as well use SMA standards. We can argue that. And it is largely our intent that when we use these working test leads, whilst extremely good, are slightly less stable for their gain and phase than our precision test leads. So we would recommend, when you're using these SMA leads, working test leads, we would use SMA calibration standards, and we would use premium standards when we're making a premium measurement using premium test leads.